The restaurant opens at 11. Dozens of meals will leave that kitchen today.
But before the first flame ignites, something else has already been running for hours. Quietly, above the ceiling, behind the walls, through ducts no guest will ever see. Every commercial kitchen produces heat, smoke, grease vapor, and moisture.
Constantly, relentlessly, in quantities most people never consider. The ventilation system is what keeps that environment functional.
Without it, kitchens stop working within minutes. The system begins with the hood. A stainless steel canopy positioned directly above the cooking line,
capturing combustion byproducts before they spread through the kitchen. But the hood is only the entry point. Behind the hood, grease-laden air travels through ductwork. Galvanized steel channels that run through walls, above ceilings, sometimes across entire floors, before reaching the exhaust fan on the roof.
This path is where maintenance begins to matter most.
Grease accumulates. Not dramatically, not all at once.
It builds slowly, in thin layers, session after session.
Each service adds a fraction of a millimeter. Over weeks, those fractions become centimeters.
When grease reaches a critical thickness,
it becomes a fuel source. A grease fire inside a duct travels fast through the path the system was designed to carry air. This is why maintenance intervals are not recommendations. They are requirements. The maintenance team arrives before the kitchen opens. Sometimes at 3 in the morning. Sometimes after the last service ends after midnight. The timing is deliberate.
The system must be cold, idle, and clear of staff. The lead technician has run this route for 11 years.
Same hoods. Different grease. He moves without hesitation. Not because the work is simple,
but because the sequence is memorized.
The first step is inspection.
Before any cleaning begins, the crew assesses the condition of filters, duct access panels, and the hood plenum, the chamber behind the filters where airflow concentrates. A grease-saturated plenum changes everything about the cleaning approach. Baffle filters, the corrugated steel panels inside the hood,
are designed to force airflow into sharp directional changes.
Grease particles, heavier than air, cannot follow those curves.
They impact the baffles and slide down into collection trays below. This is physics applied to kitchen safety.
The filters are pulled, stacked, and transported to a soaking station. Degreasers, alkaline solutions formulated specifically for cooking oil residues,
are applied and left to work.
The chemistry does what scrubbing alone cannot.
While the filters soak, the crew moves into the ductwork.
Access panels, positioned at intervals along the duct run, open to reveal the interior.
Not all buildings have them in the right locations. Some buildings require the crew to cut new access points.
Inside the duct, the work is physical.
Long-handled brushes. Scrapers designed for right-angled corners. Pressure washers fitted with narrow lances for deep penetration. The crew works section by section.
The grease must be removed, not displaced.
The duct system in a medium-sized restaurant
may span 40 to 60 linear meters,
bending around structural beams,
rising through floor assemblies,
terminating at the rooftop exhaust unit.
Every meter of that path must be documented. At the roof, the exhaust fan draws air through the entire system.
It is the engine of the ventilation circuit,
operating at high RPM, often in direct weather exposure.
Heat, rain, freezing temperatures. The fan doesn't distinguish between conditions. The fan bearings wear.
The belt connecting motor to fan wheel stretches and cracks.
Vibration mounts degrade. Each of these is a maintenance item. Each carries a failure timeline. The team checks them against service logs. Back inside the kitchen, the duct sections have been worked through. What remains is the plenum, the chamber directly behind the hood filters. This area accumulates the highest concentration of grease.
It is also the most difficult to clean properly. The pressure washer runs at temperatures above 80 degrees Celsius. At that heat, even solidified grease liquefies quickly. The water pressure carries it downward
into the collection trays, into containment bags placed below.
Nothing is allowed to drain directly.
Grease waste from commercial kitchens is regulated. It cannot be poured into municipal drains. The maintenance company is responsible for its collection and proper disposal. An environmental compliance layer built into every service visit.
The inspection goes beyond cleaning.
Each surface must be assessed after clearing. For corrosion, for weld failures, for joint separation.
Ducts that appear clean can carry structural compromises
that affect long-term airflow performance.
Fire suppression systems run alongside the ventilation system.
Nozzles embedded in the hood direct suppressant directly onto cooking surfaces and the duct opening.
These systems are tested separately,
but they are inspected during every ventilation service. The makeup air system works in parallel with the exhaust. For every volume of air pulled out of the kitchen, an equal volume must be replaced.
Without it, negative pressure builds.
Doors become difficult to open. Combustion appliances draw from the wrong air source. The makeup air unit also requires periodic filter replacement. An external intake draws in ambient air, and with it, whatever the outside carries.
Particulate matter, pollen, grease from neighboring exhausts. The filters prevent that contamination from reaching kitchen surfaces.
By 4 a.m, the crew has completed the primary duct run. Documentation begins.
Every section logged.
Every measurement recorded. The report that follows this shift will determine the next scheduled service
and flag any conditions requiring emergency attention.
Service frequency varies by kitchen type.
A high-volume burger operation, running fryers continuously,
may require monthly service. A catering facility operating 3 days per week may operate on a quarterly schedule. The standard is not fixed, it follows the grease load. Some restaurants have failed inspections not because of food handling,
but because of ventilation compliance. An unclean duct system with documented grease accumulation
can result in immediate closure.
The kitchen staff are rarely aware of how close that line sits. The filters are now clean. Pulled from the soak tank, pressure rinsed.
Inspected for baffle integrity.
Bent baffles do not flow correctly.
A deformed filter in a hood is not a cosmetic problem. It is an airflow problem.
Filters are reinstalled with care.
Alignment matters. A misseated filter creates a bypass gap
where unfiltered air can reach the duct directly.
Each filter is seated, tested for movement, confirmed in place. This takes 3 minutes.
It cannot be rushed.
The exhaust fan is inspected last. Not because it is less important, but because the rooftop work happens after all interior tasks are complete. At this hour, the roof is cold. The city below is quiet.
The fan has been running uninterrupted. The fan unit is shut down only for the duration of the belt and bearing check. Ventilation to the kitchen stops.
The crew works quickly. Every minute of shutdown is logged.
Extended downtime during a service visit can affect kitchen opening schedules.
Bearing condition is assessed by sound before the unit is opened. A healthy bearing produces no noise. A worn bearing, even before visible damage,
produces a frequency shift detectable by an experienced technician.
This is diagnostic listening.
The belt is replaced on schedule regardless of visible condition. This is predictive maintenance.
Replacing a belt before it fails costs significantly less than an emergency call during peak dinner service. The math is simple. The discipline is the practice. The fan is restarted. RPM verified against specification. Airflow confirmed at the hood level using a velometer,
a device that measures air velocity through the duct opening. The number must fall within the design specification for that kitchen.
Airflow readings below specification indicate a problem in the system. Blocked duct section. Failing fan motor. Improperly seated filter. The velometer reading narrows the diagnostic field. Without it, the technician is guessing. The service record accumulates over years. It becomes a performance history. A dataset of the system's behavior across seasons. Menu changes, ownership transitions, equipment upgrades. The best technicians read those records like a timeline. The system tells its own story. Around 5 in the morning, the cleaning chemicals are neutralized and removed. Surfaces wiped down. Access panels sealed and relabeled. The kitchen is restored to exactly the condition it must be in. For the first cook to arrive. No trace of the work is visible. The crew exits through the service corridor. Their tools loaded. Their waste containers sealed and tagged. The report transmitted to the facilities manager and the restaurant operator. The building doesn't acknowledge what happened inside it. It rarely does. At 6:45, the head chef arrives. She has no awareness that the duct above her has just been cleaned. She turns on the line. The exhaust fan pulls. The hood fills with vapor from the first burner. The system does exactly what it was designed to do. This service interval will repeat. In 4 weeks, or 8, or 12. Depending on what the grease load data shows. The maintenance company schedules the next visit before they leave. The system does not wait for problems to announce themselves. The lead technician from this crew has serviced over 400 kitchen systems in this city. He knows which restaurants push their intervals. He knows which facilities managers read the reports carefully. He has seen grease accumulation that would have ignited within 2 service cycles. He mentions it without drama. The ventilation system is not a background detail. It is a primary safety system operating under code requirements. In every licensed commercial kitchen in every city. When it fails, and without maintenance, it fails. The failure is not invisible. A grease fire in a commercial kitchen is among the fastest spreading fires in a built environment. The restaurants that operate without incident, night after night, service after service, do so because of systems functioning correctly. Not because nothing ever goes wrong, but because the interval before something goes wrong is managed continuously. Behind every meal that arrives at a table, there is a duct run cleaned at 3 a.m. A filter soaked and reinstalled. A fan belt replaced before it failed. A reading taken and logged. A technician who left before anyone arrived. The system will run again tonight. And the night after that. And sometime before next month. A crew will return to this kitchen. To begin again, precisely where the last service ended. That continuity is the system. Under this video, there's a subscribe button. It's a small action. But it helps reveal the systems most people never notice. If you're curious about how everyday life actually functions, consider subscribing. And tell us, where are you watching from? Have you ever worked behind the scenes of a system like this?